Hi, I'm your Professor Taewei Wang. This lecture is on Chapter 3 of Spurrier's and Topi's System Analysis and Design in the Age of Options. Chapter 3 is about domain modeling. In other words, domain modeling can be described as something in the database world we call conceptual modeling. There are three keywords on this title: documenting, concept, and domain. Conceptual modeling and the documenting effort in the domain area is one of the higher level documentation effort that we have in the system analysis and design process. In the traditional system analysis and design process or life cycle, this particular task or process is usually done very early in the project process. Sometimes people will use the words called logical or conceptual modeling to replace the term domain modeling. The effort of create some sort of a abstraction representation is the key to build a domain model. The benefit of doing domain model at higher level is to avoid the detail from distract you from the real problem you're trying to solve. So let's get started from the concept of domain. Another interpretation of the term domain can be viewed as the boundary of the problem that we are trying to solve. In technology development, there is a special problem in most of the organization. It's called requirement creeping. Requirement creeping means that whenever you have a system you want to build or implement in an organization, it is tempting to have added more and more feature into this particular system or software. When you add more and more feature and function into a particular software application, the project will never end. That is that you have to continuously working on that project, and the scope and scale of the project will continue to grow. A lot of time you will end up with a monster system that is not very easy to use or expand beyond the user's requirement. A lot of feature will be built without any serious consideration and waste a lot of resource in there, and very few people will use that feature. In order to avoid that endless expanding the boundary or the size of your project, it is very important to define your domain or define the system boundary. And this is what domain modeling is very focused on. Domain modeling starts by identifying the objects that can be identified or used in the software system. These objects can include the user, the interface, the program logic, events, or some transaction that you try to record, and everything that you're concerned in the business process or operation will become part of the domain. In order to document all these relevant objects, you have to create a model to systematically or structurally organize them together so you can see the whole thing in a more systematic way. To do so, the most common used tools are either something what we call entity relationship diagram, or the other one is the UML class diagram. When we read the chapter in the following slides, you will find that these two types of modeling are very similar to each other. Both of them contain the three important elements in the model: entities, attributes, and relationship. In my course design, the entity relationship diagram will be discussed more in our database course in our curriculum. But the UML object class diagram will be discussed more and as a focus in our class here. But of course, because this is a more conceptual level model, you can sort of use them interchangeably, even though the terminology is slightly different from one model to the other. So let's take a look at what we have in these two types of models. Now, one of the warning of the domain modeling or conceptual modeling that we are doing here is that the second bullet point you see on 3-7, the PowerPoint slide from the textbook. Please do not focus on the characteristic of any technical system used for enabling process. In other textbooks, people will tell you that do not try to model the physical technology you're trying to use. For example, do not model, say, for example, hardware that you have an iPhone or Android phone, or use a particular software system like Microsoft Word or Microsoft Office. Those type of description are very detailed and technical at the implementation level. Those are the things we try to avoid at domain modeling. And again, one of the purpose of domain modeling is detach you from the technical detail or day-to-day operation detail and rather focus on more important concept or business process or the data item that you try to identify and manage. Sometimes a domain model can work as a contract of some sort in a technology project. You probably heard about this term called call for proposal or call for quotation. So both call for proposal and call for quotation require some sort of a higher level description of the project, and one of the important documents to be provided in such agreement is typically a domain model. That is that the object or the classes or the data item you try to deliver and manage in a particular project. Let me try to give you an example. For example, if you are engaged in an inventory project, you will probably say, I'm going to be managing the inventory, the item, the stock keeping unit, the pick and stock, that sort of operation. And you will not be managing the client customer. And so the client customer will not show up in your domain model. Now earlier we talked about this problem creeping, and client customer, they are actually related to the inventory in some way because when a customer or client buying stuff from your inventory have to make adjustment accordingly based on customer's order. However, if you are keep adding the customer information here, the next thing you will probably focus will be, well, maybe I should add the vendor's information as well. And after you add vendor's information, you will add vendor's information to keep track the entire supply chain. So it's very likely when you start working on an internal warehouse inventory system, very quickly you are building a supply chain management software. And that is a typical creeping problem in system development. So in order to avoid that, you have to be very carefully select the classes or the entity that you use in your domain model. So as we discussed earlier, there are two methods in building the domain model. One is entity relationship diagram. The second method is the UML class diagram. Again, since both of them are very similar, we will start by looking at example of a ER diagram or entity relationship diagram, and then convert the notation into the UML notation. And in the class exercise, when you're going to be doing in your assignment, we will be using the UML notation. From a certain perspective, entity relationship diagram is actually the father of a UML class diagram, and a long history of how the modeling standard evolved over time can be given in about 1 hour, maybe 2 hour lecture. But here, let's just try to say that both modeling methods learn from each other, and by including and enhance the concept or the notation they are using in their model, and the end result is we see two very similar modeling methods. So both methods start by identify the concept called entities. And entity, again, in the UML model, we call them classes. And entity classes, they are referring to a group of objects that have been kind of put together. So let me try to emphasize this word. A group, multiple instances of the object to put together become an entity or a class. So one of the first things we learn in a domain model is that usually we identify an entity that you have to look for in your system. There are multiple occurrences of that particular concept or things that you try to manage. So on the slide that you see two examples, sales, there are multiple sales. People buy stuff all the time from business. Their product, multiple product is very typical in the business operation. So both of them are classified and can be considered a class or an entity. On the other hand, there are something that when we are trying to do things, say for example, if you're a business trying to buy a product from, say, Apple company. So you say, okay, Apple, referring to the company that is usually not a good entity to be considered. It could be, but Apple itself is one singular company, it's one occurrence of something. And so when you're modeling that in your domain, there's something wrong. It's not something you need to manage. It's one single occurrence that could be an external entity. Sometimes we call them external entity, or an actor in your business process. It is not a class or not an entity you're trying to manage in your business operation. Especially, it's not an entity you try to manage or try to utilize in your software application. And once you identify the entity or the group of objects that could have important role in your business operation, in your software, then the next thing to do is to identify their attribute, some of the property of that particular events or things or items or object or people or animal, whatever thing that you try to manage, and try to identify important property to describe that particular entity. And once you be able to achieve that, then you come up with this description of an entity with attribute. And to facilitate the idea of managing these objects or concept, that we usually identify one particular attribute as something what we call as identifier. And this identifier is marked with underline notation in both ER diagram as well as in UML diagram. So this underline notation is important, and later when we spend more time in the modeling exercise, I'll explain that pay attention to the underline that items or object that you are dealing with. Sometimes they are considered to be the identifier or keys in database. Sometimes they are considered to be the instance occurrence of an object. And most of the attribute has one single value, but sometimes the attribute can have multiple value. This is called a multi-valued attribute. In the traditional ER diagram, multi-value attribute is something that we try to avoid, because this is in conflict with the database, relational database design. But in a software development world, especially in a programming world, multi-value attribute is something that very common and can be accepted. And once you have all the important entity that to be identified exists already in your model or in your domain, the next thing to do is to identify the relationship among these entities or classes. And there are three basic type of relationship. One is the unary relationship, a group of entity or a group of object related to the same group. It's called a unary relationship. A group related to another different group is called a binary. Or you have more than two group, three group, it's called ternary relationship. Can have more than three, 4 group, 5 group. Those are called a higher degree relationship. But typically we try to manage or try to document only up to the 3 degree of the relationship. More than 3 degrees of relationship usually will become a very challenging job in our human mind to manage a system. It's a system, if you design using higher level or higher degree relationship, it will be very difficult for regular person to understand. Translate into the future system you're designing, it will be too complicated, not very useful for our human usage. And this is the example of a unary relationship. A product is related to another product. For a more detailed discussion of this type of relationship, we'll probably use an exercise to do so. And this relationship is a typical something what we call a bill of material or product structure relationship. It's usually described from the product to its parts. So you have a car. Car is a product. And engine is also another product. But engine is part of the car. And both of them are products. So engine and car sometimes will be going into this called unary relationship and try to build this bill of material in the process. Just for the purpose of your understanding or memory, I put abbreviation or the BOM here stands for bill of material as an example of a unary relationship. Hopefully you remember this term from your production and operation management class. The most common relationship in an entity relationship diagram or in a UML class diagram is the binary relationship. Binary means there are two entities related to each other in some sort of a responsibility way. So one entity is responsible for a certain job for another entity. So on the diagram that you can see, we have an entity called sales. The other entity is called employee. So employee is responsible for handling the sales. And so if you can imagine that you are working for a car dealership and every sales is handled by a particular salesperson, and you need to have a record of that particular salesperson in that sales event or sales document. And so that is part of the nature of why we are building this domain model. Try to document, keep track of all these things and events happen in your business operation. So in this example, we have a ternary relationship describing a job, a store, and employee. This is actually a typical something what we call the project management. A lot of time, project management involve entity from multiple interest groups. Say, for example, if you are building a house, very quickly, I believe many of you is going to be buying or purchasing the first house in your life as a young college graduate or as a young graduate student. That is likely you'll be involving some sort of a business with a realtor, and you need to have probably some sort of a design to describe your house and how much money and the contract and the bank involved. So the realtor, the bank, and the seller and you're looking at the 3-4 direction relationship, and usually we describe that kind of relationship using a ternary or higher level relationship to describe the transaction you are get yourself into. So once you have entity, you have attribute, and you have relationship, the basic concept of your domain is pretty much organized and structured and represent in your model. To provide more detail, the next step to do is to identify how these entities related to each other in a more specific way. Now, in the entity relationship diagram, we call this cardinality. How one entity object related to another entity's object. This could have one-to-many, one-to-one, and many-to-many relationship. In the ER diagram notation, we use this notation called the crowfoot notation. It looks like a crowfoot without explaining too much because we are not focusing on ER diagram here. Let me just say that you see this crowfoot, the three-legged notation represent many. If you see the bar, it represents one, and the O or zero, the circle, represent optional or zero. So this diagram describes a relationship says, okay, every employee can handle zero or optional, zero sale or many sale. So looking from the employee's perspective. Looking from sales perspective, every sales is being handled by one and only one employee. So there are two on each side. The one notation close to the entity is the many side, or actually and the one close to the other side is the minimal side. Well, it's actually not many, I'm sorry. It should be minimal and maxima. So we have the term minimal cardinality and maximal cardinality. So the minimal cardinality for cell on the cell side is 0. The maximum is many. On the other side, the minimal for employee is 1 and the maxima is 1. So when you have minimal and maxima all equal to 1, you have 1 and only 1. That is actually one of the constraints in a relationship. And this example is a different, well, same entity but describing a different relationship. It's a many-to-many relationship. So we're looking at each cell has multiple products. Every product can exist in multiple cells. And the minimal cardinality on both sides are different. One is optional, the other is required. Simply saying, this particular model you see here says every cell needs to have a product, but a product may not be a cell in or exist in any cell. An example of a one-to-one relationship here. Now, when we run the example to this point, I have one warning to you. That is that there is no particular rules to say that one entity have to relate it to another entity in one way or the other. For example, student and professor, the relationship between you and me, and what is the cardinality between you and me? Some people say, okay, one to many because I'm one professor, you are many students in this classroom. But in another situation, you register to the university class system. You as a student, you're actually facing multiple class and facing multiple professor. So in that situation, you become many to many. And in some other situation, if you sign up for a seminar or project class, you're dealing with the professor one-to-one. So in different situations, you may have different type of relationship. And this is one of the things that many, you can say the undergraduate student or new student learning model can make a mistake. You would think of that anytime we model, there is a correct answer. The real situation is it really depends on your business operation or business rule or the system you're in, and the same concept can have different relationship with each other. And that type of relationship is something that in the UML or in the object world we call multimorphism, and that is not something we're going to be talking about here. We're going to be talking about that concept later when we're dealing with more detail in the design model. And some ER diagram will describe the model even more by identifying the role and by identify the job to be performed during the business operation or in the domain model. But typically that I would recommend that's enough. Do not put too much detail in the domain model. And in the more detail you put into the domain model, the more constraint you have in the future implementation. The important job again is to identify entity, attribute, and relationship. Nothing more. If you identified roles, you identified the responsibility, that become too much detail in the domain model. So when you start building your project or identify the scope of your project, you start to grow more than one entity and relate them together and become a more complete entity relationship diagram, such as this one. And this diagram actually represents a very important concept we call the line item pattern in the conceptual domain modeling world. The line item concept is actually one of the implementation skill that we use in database world to convert many-to-many relationship into two one-to-many relationship. The reason that you want to have a one-to-many relationship instead of many-to-many is because in traditional classical relational database, there's no way you can implement many-to-many relationship in the database. But the detail of how and why this is converted into a one-to-many relationship will be leave in another lecture for discussion. And for our learning concern, I think that pretty much all you need to learn from the entity relationship diagram. But if you read the chapter a little bit more in more detail, you'll find that the ER diagram we are talking about here is called extended ER diagram. Extended ER diagram borrow a lot of concept from class diagram to include different type of relationship, and this type of relationship is called supertype and subtype or generalization specification relationship, and it's represented in a different way. In class diagram model, we call this type of relationship as inheritance relationship. And for most of you who have already taken object-oriented programming language, you probably heard about this term called inheritance. And this is a type of model try to describe that kind of relationship. So we have to switch gear to UML class diagram. That is the tool we are using in this class. So there's a mapping between the terminology used in ER diagram and the class diagram. So this particular slide gives you sort of like the mapping in between. And there are a few important key points. One is entity is called class, and the other is that the association is called the association class, and cardinality is called the multiplicity. UML notation, very similar to ER diagram notation, but as you can probably see, there is no so-called primary key in the UML notation. And the relationship and multiplicity is represented differently. And this diagram show a aggregation or something what we call the composition relationship, and we have an exercise doing this. But for now, that we can see that the relationship, the cardinality or the multiplicity is represented in differently in both the term they use, but also in the notation they are using. And this is another type of aggregation relationship called the composition. It's also a one-to-many relationship. And this now is an example of a superclass or subclass relationship. In the UML, we call that inheritance relationship. The parent class, or the bigger or more abstract concept, is represented by this triangle arrowhead pointing to the more abstract concept. And multiplicity, instead of using this called the Crowfoot notation, we are using the number notation. We also, for every end of relationship, we also have minimal and the maxima multiplicity is represented by a number or by an asterisk to represent many. The many side can actually become a real number. It can be 1, 2, 3, 4, 5, any number. Be more specific and more, you can say more detail in the UML model compared to the entity relationship model. There are also new notations, say for example association class, to represent the concept of a one-to-many notation in a ER diagram we see earlier as our line item pattern I mentioned earlier. So put things together, you have a UML diagram or UML class diagram to be specific, used to represent the domain entity, an entity including all the domain object that is involved or include in your system boundary, include in the scale of your project you try to manage it. So in this example you're seeing here, we're looking at a system that deal with employee working in a store, sort of handling the sales, and the sales transaction is a typical model we are dealing with. And this is actually a very typical sort of a partial project for a point of sale system that we deal with in the typical information system project. And this is usually a typical first project in the information system that we are adopting in a typical organization. All right, so we are going to be learning how to build this later in our class, but for now we have a sense of what is the purpose of domain model and the three important elements that we're using domain model, class, attribute and relationship, or entity, attribute and relationship. Depends on which method you are using. It's either entity relationship diagram method or class diagram method, and we'll focus more on class diagram. Until next time, and we will discuss this type of model more in another lecture. Ciao.